Hello, everyone. Today, welcome to Puzzle Time with MoMath. Oh, I guess I should have a screen that says, welcome to Puzzle Time with MoMath and MathPickle. So if you guys could just imagine that for today, that would be good.
Okay, imagining in progress.
Yeah. So today we are going to start off with a simple number. This is a number that you might have seen before. It's a 1.
Yes.
The loneliest number.
Yeah.
Yeah. The loneliest number apart from 0.
It's very lonely. And this number, we are going to add to it. We're going to make other numbers. And what number would you like to start with? Start with something small, bigger than 1, but make it pretty small. Etaf, welcome. Tess and Karen, welcome. Good. Yeah, let's make this next number a number that's really quite small. Oscar, it's your choice. Make it like as small as
1.5.
And it has to be an integer.
Then 2.
2, okay.
Yep.
Okay, so.
That's what I was going to say. It would be a funny joke if you just literally drew the 2 very tiny. And it would be a small number.
Yeah, but
1.1.
The joke wouldn't be long-lived.
Yep.
So the next thing that we need to do is we need to find the next number that shares a factor with 2 that we haven't used before. Okay, so tell me about a factor of a number. Let's say the number 18. Tell me about the factors of 18. Amelia, do you know what a factor of 18 might be? Just if you named one of them. So it's a number that you could
that you can, like, a number that if you times a certain number by 18, you'll get that number.
It would be a number like 6, because 18 divided by 6 is an integer. Okay, so that would be a factor. So 6 is a factor of 18. Can you name any other factors of 18? Any other numbers that if you take that number and divide it by, and take 18 divided by something, you get an integer. You get another, I guess it would be another number in this list. So because 18 divided by 6 is equal to 3, you know that 18 divided by 3 would be equal to 6. So 3 would be another factor of 18. So those 2 would for sure work. Yeah. So let's see, what else would work? Nathan, do you want to?
Sure. Another factor would be 9.
9.
9. And because 18 divided by 9, 18 divided by 9 is 2, so that means 2 is a factor as well.
Okay. And Oscar, have we found all of the factors?
Well, there's still 1 in itself. Those are all the factors.
Okay, yeah, we could say 18.
So there's 1 in 18.
Yeah. So those ones there. Now, this isn't pretty. Normally, we would maybe write this in order. So we might go 18, the largest, then the next largest, then the next largest, then the next largest, next largest, and next largest. So that's how we might write it.
Yeah,
So,
that's prettier.
Yeah, it definitely is. This is ugly. Let's get rid of it. Avocado cream does not approve. But this one, avocado cream approves of. So we're going to stick with this more beautified version. So here, we come up with a new number. Who's talking? Sorry.
So we're trying to find the integers of that number?
So you are trying to find the smallest integer that you haven't used yet that shares a factor with 2. What is the smallest number that if you like if these are what are the factors of 2? The factors of 2 would be Tess and Karen, go ahead. Tell me about what the factors of 2 are.
1 and 2.
Yeah, just 1 and 2. I'm going to put a 2 and 1 just because it looks like I adopted the largest one first over here. So these are the only 2 factors. So I'm asking you, what is the smallest number that we haven't yet seen, that we haven't yet used? We've used 1 and 2. What's the smallest number that we haven't seen that has one of these 2 factors in it? Now, of course, all numbers are going to have 1 in it, right? So like if we choose 3, well, of course that's going to work. So the 1 here is kind of cheating. It's not going to produce any interesting results. So I'm going to, avocado cream got rid of this. I am going to say we are never going to look at this 1 ever. Okay.
1 is not there, also because we've already used it.
No. Because 3, okay, 3 would have 1 as a factor. Okay, so, and 2 would have 1 as a factor. Okay, so yeah, so we would, the smallest one would be a 3, but we're not including the 1s anymore.
Yeah.
Okay, so I want Seth, can you tell me an integer, the smallest possible integer
4.
that shares
Just 2 squared 4.
4, okay, and 4 would have factors of 4, 2, and 1. And indeed, you're right. There's a 2 in common with both of these. So 4 absolutely works here. Yeah. Let's go with Solly. Go ahead, Solly. Tell me. Oh, sorry, we got rid of the 1. We're not using the 1 anymore. Okay.
Oh, we just doubling the previous number? Because the next one would be the
previous number. We're just using the previous number, Solly. So I want to know the smallest number that shares a factor with 4 that we have not used before. We've used the 1, we've used the 2. What's the smallest number that we have not used before that shares one of these factors?
6.
Yeah, for sure. Let's look at 6.
Can't we just do every single even number from here?
That is a great conjecture, and that is the Solly conjecture. 6, 3, 2, 1.
But we're not using the 1.
So Solly's conjecture is that we should keep on going here with 8, and then 10, and then 12, and then 14. We should keep on going.
No,
right?
Wait. Yeah, I think so. That's because each one has the 2 in common.
That's right. So that's got to be true.
But after the 6, 3 is smaller than 8.
Oh, the 3. Yes. So see, the 3 is smaller than 8. We haven't used the 3 yet in this sequence.
Oh.
So the 3 comes before the 8. That's right. Okay. So we've got the 3 here.
But 3 is prime, so the next number has to be a 9.
Yeah, because the only factors of 3 are 3 and 1, but we're not looking at the 1 anymore. I'm not going to write it anymore because I just forget to get rid of it. Yeah, no, I guess I should keep on writing it and then getting rid of it. That's clear. That's better. Okay. So indeed, we are looking for the smallest number that shares a factor with 3 that we haven't used yet. And Solly, you're exactly right. That would be 9. So that 9, the factors are 9, 3, and 1.
That we can't use.
That's right. Okay, next, I am looking avocado cream. I'm looking for a number that we haven't used yet that shares a factor with 9.
Ooh. So we're not counting 1 anymore. We already have 9 down technically, and we have 3.
Technically. No, we don't. You don't need to say technically.
Yeah.
9 is done. It's
yeah,
done.
9 is there.
Yep.
And 3 is there. So we've run into a problem.
Why not 12?
No problem. Just keep on looking for some number that has a factor of that it shares with a 9. What other numbers would share a factor of a 3? What other numbers would share a factor of a 9?
18.
18, absolutely. 18 would work. 18 would work. I'm not sure it's the smallest one. We'll
12, I think. 12,
Yeah,
right?
it's 12.
12.
12.
Good avocado cream. Yes, good. Okay, so 12 is the smallest one that we can use.
And
Yeah.
now
So let's look at all of the factors of 12.
4, 1. 4, 3, 12, 1.
Ethan, would you like to tell me all of the factors of 12?
4, 3, 6, 2. 12, 1.
8. No, wait. Would 8 work next? Because
Okay, so first of all, we're getting the factors of 12. Factors of 12. Seth, go ahead.
factors of 12. Okay. 1, 2, 3, 4, 6. Okay. 1, 2, 3, 4, 6, 12.
Yeah, and I ran out of space. So this is not going to meet the approval of Avocado Cat's nice crisp system, but you can see them all there. So, oh my goodness, we want the next number. Amelia, do you have any idea the smallest number that we could add that would share a factor with 12 that we haven't used yet? So it would have to share a factor of 2, 3, 4, 6, or 12. There's a lot to choose from there.
Well, what do you think? Look at numbers that haven't been used yet, and see if you can figure out which one would have a factor with 1, 2, 3, 4, 5. 6 has been used. Does 7 work? Does 8 work?
No. Oh, what's inside this?
Does 10 work?
So 10's even, so it would share, because 10 would be 2 times 5, it would share a factor of 2. So 10 might work, but you might be able to find something smaller than 10, Amelia. Something also that shares a factor of 2.
8.
8. No, oh yeah, yep, because that would be 2 times 4. That would work. So yeah, then that looks smaller. So there we go. So yeah, that looks good. And let's see. We are going to continue this until, let's say, until we hit a number more than, Nathan, tell me how high you want to go here. Maybe till 20, maybe.
I was thinking like I was wanting to like say the next number, but I can do that as well. So
you want to do what? So
I was hoping to say the next number as well. So
yes, please do, and tell me how high you would like us to keep going.
The next number in this sequence is 10 because the factors of 8 are 8, 2, 4, and 1. So
yes.
So 10 has a factor of 2 in it.
Okay, I agree.
So the numbers that we should be reaching, I think the highest numbers that we should be reaching is perhaps maybe let's go with 20.
Okay.
Let's go with 20 because while we did get to 12, we did drop down to 8, so we don't know how wild this roller coaster could go.
Yeah. I don't want to go crazy, but going till 20, I think that's a reasonable amount.
All right.
Yeah. Taco Cat, can you do a couple of numbers now?
Gord.
Well, I would do in this position 12 because.
12. But we've already seen 12, Taco Cat.
Oh yeah. I thought we were doing it in order. Well, then the smallest number possible, I'd say 14. No, 14. We don't have a 7. Although we can do.
Not that.
5?
Well, then probably 16.
It's 5.
So Taco Cat's saying 14 next because we've done the 12. And Oscar, you're saying 5?
Yes, we haven't done 5 yet, and it's a factor of 10.
Okay, so 5, yeah. And we haven't done it yet. Taco Cat, okay. Are you? Yeah. So 5 looks right. And 5 has got, certainly it does have the same factor. So that's right, 5. And then, just 1.
Can
okay. Taco Cat, do another one. You're at 5 now.
Well, here I think we've used up all the numbers except 7, but we don't have a 7. We can't make a 7. So 14.
It's 5. It's 5. We're at 5 now.
Oh yeah. Well, then we can only do 15.
Yeah, that's right.
It's time for a poll.
Oh, it is. Thank you very much. We are taking a break to do a poll. There we go, everybody. Okay. How many people think that this could go on forever? If we were to sit here for 10 years. Forever. Yeah.
I noticed
they're
that
infinite numbers. Obviously, we can.
Yeah.
Also, I noticed that we keep going back so oftentimes we'll find something divisible by a prime number we have not done yet, and then we will do that prime number and then do those prime numbers multiples by other prime numbers we have found until we get to a different prime number and go back on that prime number and so on.
Yeah, so there is this kind of back and forth that has something to do with prime numbers. Yeah, that's a good observation, Seth. Okay, let's go with a, stop sharing that.
Got some hands up.
Yes, Solly, go ahead. Where do we go from 15?
My hand was going to be the poll, but the next one has to be, doesn't have to be, but the next one could 15, 5 and 3.
Oh yeah, I should write down 15. So 15 is, I will just say it's 15, and then there's a 5, and then there's
I say 18. Does anyone disagree?
Anyone disagree with an 18? 18 going once, 18 going twice, 18 sold. We've sold an 18. Okay, so 18, we've already done 18 up here. We've got an 18, a 9, a 6, a 3, and a 2. And again, I need to get rid of this one.
Wait, not uh-oh.
Okay. Amelia, yeah, your hand. You keep on getting these hard ones, Amelia. Look at this one. This one's, every time I call on you, we have this giant list of numbers for you to look at.
You've already used all of them.
Okay.
5, 6 to 7 work.
7.
No, does 8 work? No. 9, 10. Does 11 work?
Don't think so.
No, 11 would lead you to go. What about 12? No. What about 13?
13.
What about 14?
Yeah, 14.
Oh, yeah.
Yep, 14.
Yeah.
Now we can use
7 because that's a new prime number. Yay.
Yay.
14.
that. We have to
7. We have a new prime number, 7.
14.
Yeah.
It's 7 snacks.
That means we have to exceed our limit of 20 with 21.
And oh yes, so I think we are going to exceed it. So here we go to 7, and then
the 21,
and then we go to the 21, and then we're finished. Okay. So
Yay.
of course this keeps on going. Of course, this keeps on going forever. We could sit here for the rest of our lives computing this sequence.
And it would not be done because
it might be done. Maybe we could reach infinity if we lived a very long time, but probably it would be difficult to get there.
Yeah, because
infinite.
There's a lot of numbers that are still being discovered.
Yeah. So here we go. This is the start of today's session. Now I am going to stop this. I am going to I'm going to have, if Tess and Karen want to introduce themselves to the group, say where they're from, and just something fun about themselves. That would be fun. Oh yeah, and why you love pickles so much. That's our favorite question for people. Why do you like pickles so much? Why is it the only thing that you eat for breakfast every day? Do you know that that's not healthy? Tess and Karen.
Probably is not healthy.
Tess and Karen live in Queens, and I like Pickles pineapple. That's my favorite pickle.
That's okay.
Pickled fruits.
Pickled mango is not
for
so
sale.
Pickled mango's good.
I've never tried pickled anything.
The only type of pickled thing I've ever tried is a
and then
it's
pickles, and then I think in 5th place comes pickled watermelon.
Oh, I saw that today's link to join the meeting was better cucumber.
Okay, everybody.
Cucumber. That's hilarious.
Cucumbers are the original form of pickle, a cucumber.
And everyone was silent. And here we go. This looks totally unrelated. Here we have a bunch of animals at the bottom.
Is that Socrates?
You guys have to figure out what is their common ancestor, their earliest, their latest common ancestor. So if you go back generation after generation, how far back do you have to go before these, according to the theory of evolution, how far back do you have to go before two of these creatures would have a common ancestor? So do we have a vote? This looks totally not what we were doing right now, but we will see the connection. Oscar, do you want to choose the two creatures that you think are, if you go back let's say we go back 100,000 years, 100 million years.
I think maybe it will like ant that's the fourth to the right, and the like firefly right next to it.
Okay. The first animals that are connected, if you go back in time, are the bat and the orca. They only separated around 60 million years ago. So if you went back 60 million years ago, there were not orcas, there were not bats, but things evolved from both of those. Those of you who follow evolution. So next question, what were the next two creatures? Solly, go ahead. What do you think? Now we can look at the DNA to check this out. So we do have a lot of really interesting science behind this. Go ahead.
I see the fish.
Yeah.
And the ant.
The fish and
the ant.
The fish and the ant?
Yeah.
Okay. And the answer is the fox and the combined ancestor of the bat and the orca. Okay, next, Nathan. Who do you think?
Not human.
Human?
I think that the next two that are related are the butterfly and the dragonfly.
Now, we're not quite talking related. We're also not talking similarity in DNA. What we are talking about is how far back in years do you have to go before they separated from each other, before they had a common mother, okay?
Okay, so how far back would we go? I think that we would have to go back. Actually, I'm going to keep it simple. I'm going to say
I'm asking for the two creatures. The next creature.
Humans and the kangaroos, because those are the two next on the list, and those are mammals.
Okay, I'm actually going to go for, I'm going to say the snake and the fish.
Okay, and the answer is humans and the blended
Is this going to be a train?
Bat and orca.
I think this is going to be a chain.
You see some kind of pattern, Nathan?
Yeah.
Yeah?
Yeah, except I think it's going to break pretty soon.
Okay.
I think that's going to break.
Okay, you get one more chance. One more chance.
Okay. Okay. I'm going to say that the humans and the kangaroo are next. And they just go a little bit for So
interesting.
Pretty much right.
Did you know that
it's
humans,
not humans. Sorry,
share more?
Guys, it's not humans and the kangaroos. It's the common ancestor between humans, foxes, orcas, and bats. So way back here, they didn't look like humans or foxes or orcas or bats. Okay, this is probably much more like some kind of rat-like creature. Okay, and whenever you get back to between a kangaroo and these other rat-like creatures here, it's probably pretty rat-like or mouse-like. Okay, so it was the common ancestor here of all of these.
Okay.
Okay, get it? Yeah.
Yeah.
Okay. Next, Amelia. Any idea which pair of animals, if you keep on going back, which pair of animals has a common ancestor next?
Well,
this is not easy. Right?
Following the pattern we've established, it's gone from the bat to the orca to the fox to the human to the kangaroo. And it just keeps going in a line. And so...
But you remember, I keep on, by pure coincidence, I keep on asking you at the wrong time. And you get the one that just goes, no, by pure coincidence. And guess what? Now it's the ant and the butterfly.
Oh, of course.
Of course.
Yeah.
So
I wouldn't have got that either.
Yeah.
You planned that.
such an ugly gap.
Okay. So now I'm just going to have a quick vote. People can just say yes or no. I'm going to try to remember what they are. I think it might be the owl and the snake. I think. Anyone want to agree with me? Thumbs up or disagree? Okay, let's just see. Yes, okay. I think that. Now I'm going to guess. Oh, I don't know what it is now. I don't remember anymore.
You're confused.
So now I'm just going to go through. I'm going to keep on adding them, going back in time, looking for common ancestors. So the next, around 300 million years ago, the mammals and the reptiles, or the maybe it was amphibian. No, that's the reptiles. The mammals and the reptiles had a common ancestor. And back further, then the amphibians join us. And going back further, we have I don't know what this is called. It's a seahorse, but I don't know the general term.
What's a seahorse?
Yeah, this one's a seahorse and a fish.
Wait, what type of animal is a tardigrade?
Sorry?
What type of animal is a tardigrade? It's also known as water bear.
Don't know. I don't know. I'm not a biologist, but I did get these numbers from a reputable source. Okay, let's see. Here we go. The arachnids and crustaceans, and then we have the dragonflies joining the other insects. And then, lastly, the starfish. And then those whole two groups come together. Okay, so there we go. Those are the big groups. Now, we're going to do the exact same thing with numbers. How are we going to do this? Well, we're going to do the exact same thing. This is the second number. Oscar chose number 2. Okay, and then he carried out this calculations here, and we got this. Okay, so here we go. We are going to go back to the other screen share, and you guys are going to.
It's going to be 2 and 4.
I actually.
So no. So Oscar started with the 2. This is the whole genetic sequence, if you like, starting at 2. Now we're going to look at the number 3. What happens if you start at 3 or at 4 or what? Which two of these numbers, which ones do you think might have a common genetic sequence with 2? Do you have any ideas? Chai, do you have an idea about which number you would like to start with that might have a common kind of genetic sequence to this one? Isn't that like a crazy question?
Yeah. You mean like what has a common 1 to 3, or
one that looks very similar to this one? It's a crazy question, isn't it? Yeah. And any other? Steve, any ideas?
I would say 4.
4. Okay. So, Seth, do you have an idea?
Say 4 as well, because it's literally just 2 squared. So.
Okay. Solly, is there Nathan? Solly, what do you think? Avocado cream. Are you happy with 4?
Yeah.
Okay.
Yeah, I think I'm pretty happy with 4.
Okay.
2 is literally like 4 is literally right after 2, and also 4 has 2 in its DNA. If you want to be talking about that kind of definition.
Okay, so I'm going to get you guys to spend the next 1 minute 30 seconds, starting at 1, going to 4, and then I want to know what comes next. So you're going to be looking at numbers that share a common factor with 4. Okay, and then I want you to develop this sequence.
Actually, I don't think it will be that different because if we do 4s and 2, then we'd have to go to 6, and then it's basically the same pattern from there.
So Nathan is saying that we go 1, 4, and then 2.
And then 6.
And then 6.
And then 3. And then 9. And then 12.
Oh, how are you doing this so fast, Nathan? Nathan, how are you doing it so fast?
Well, I saw that before, and then 2, after 2, we have to do 6 because we can't do 4 again. So we have to do 6, but then 6 comes 3, and then with 3 comes 9. And I saw that after the 2, every element in the first pattern matches up with every element in this new pattern.
Yeah, so that's exactly right. So the 2 patterns are the DNA is like really closely connected. So yeah, that's exactly right. What would you guess would be a very different sequence for this? Or what would you guess would be a very similar sequence to this?
I'd say that one way we can really spice things up is by starting with 21, the number we ended on in the first pattern, and then just put ... I wanted to see what happens if we start with 1 and go to 21.
Okay, so if you do that, it will really spice things up, but it could spice things up so much that we might not get through in the next 6 minutes. I'm looking for getting somewhere in the next 6 minutes that would be maybe useful. What small number would you like to try that's maybe got a similar sequence to the 1, 2 and the 1, 4 sequence? So what other sequence?
See what happens if we go 1, 6.
Okay, so 1, 6 should be pretty similar, right?
Yeah.
So I'm going to take this off. Or maybe I won't. I'll just. Okay, Solly, you can remove that for now. I'll bring this back if we need it. Or maybe I'll just copy it. Yeah, I'll just copy it. Okay. 1, 6, 3, 9, 12, 8, 10, 5, 15, 18. That's good enough. 14.
I think that starts to create a similar sequence starting from around the 12.
After 6 comes 2. And
right.
After 2 comes 4.
Okay, so just that's okay, right? So for those of us who are following slower, from 4, let's look at the factors of 4. The factors of 4 are 4, 2, and 1. And we're looking for a number that we haven't used yet that shares one of those. So that's going to be, I guess, the next even number. Next even number.
Because we already have 6, we can't put 6 after 4, so then we have to jump to 8.
Okay. Yeah.
Now with 8, we have the factors of 8, 4, 2, and 1. So now that we have 10 as an open slot, we can do 10.
Sure.
Because that's the next even number in line. And then after 10, we haven't used 5 yet. So let's do 5.
Right, agreed. Okay.
And that's where we run it. And that's where we find out that we have to do 15 next because 5, the only factor is 5 and 1.
Then you do 3.
And we're just copying here. Look.
However,
8, 10, 5, 15. So it looks like
then there's a 3, not a.
It looks like we're copying from here to here. It looks like we're copying. Is that how many people think that we are starting our genetic sequence similarity here? And both of them. How many people thumbs up? Yeah, we've started the common sequence here. Seth, Steve is down. Seth is thumbs up. Solly, I can't see a thumb. Tess is thumbs up. Amelia and Aaron are thumbs down. So this is a mixed one. Avocado cream is thumbs up. Nathan is...
This is actually a definite thumbs down, because if you look at this closely, you'll realize that we haven't used 3 yet. And 3 is a factor of 15. So that means we can put 3 in. And then...
Oh, no. Yeah, you're right. So we don't go to 18 now.
We go to 3.
So we still are not on the same.
Never expect anything from this sequence. Let me tell you that. Never expect anything.
Yeah.
There's always just that one thing that goes, no.
Avocado cream. What do you think is coming next? We've got the 3 here. So, so Nathan, now it's avocado cream's turn. And avocado cream.
So I can put
3.
any factor of 3.
Factor of 3, and I've forgotten to get rid of all of the ones. I've forgotten to get rid of all of these ones. There we go. Okay.
So I was thinking that we could do 9, because that's a factor, and we have not used it yet. So
yeah, no, you're totally right. Totally right. Okay. Let's go with Oscar. Are you around?
Yes, and it's 12, and then we start to get something a bit similar with before the red.
So you're seeing this here.
Starting from the 3.
Here. Now we're starting to copy. Right?
Although that won't last for long, because right after the orange, there's red.
Yeah. So it's not perfect, but you think it's good enough? You think I should hold a poll right now and see how many people agree that from now on it's going to repeat?
Yeah.
Okay. From now on it's going to repeat. You can go thumbs down. Or you can go like Steve, just thumbs across, or you can go thumbs up like Seth. You can go to thumbs like this, like Steve, or like Solly. You can just say, "Oh yeah, Solly's thumbs up." It repeats.
I'm just gonna go with this because I'm not sure.
Okay, so avocado cream and Steve are on the same page. Chai's a thumbs down. This is not going to repeat yet. This is a totally different part of the sequence here. So let's see where we go from here. Tess and Karen, what do we do after the 12?
So we're going to pass because we lost the actual participant.
Okay. Amelia and Aaron, you were thumbs down on this, repeating after this, or your thumbs up, or where are you?
It used to be thumbs up, and then I realized 14 comes next, not 18.
Oh, right. Okay.
Now comes 8.
And in a way, I should really do this in a way that it's obvious how many we've done so far. Because of course, if these aren't lined up, it would mean that there's numbers that we've skipped. And of course, we might go back and pick those numbers up. So you might be able to think of something like that. Anyway, let's keep going. So yeah, 14.
That's 16.
The next is 16?
No, the next is 7.
Yeah.
Okay, yep. Okay, because that's the smallest one, yeah.
Then 21.
And then 21, yeah. Yep, I agree.
18.
And now 18. Okay.
14.
Now it's used the same amount of numbers. Now it's got a chance.
Now it's got a chance. I agree. I think that this is interesting. Yeah, I think this is maybe the point. How many people are going to say thumbs up? I haven't checked this up. I'm gonna be with the Steve man. I'm gonna go sideways. How confident am I here? I am. Oh, I'm gonna go thumbs up on this. Oh, but Chai's thumbs down. Solly's thumbs down. No, I'm not so sure.
I'm going to go with Amelia, who says never trust the sequence.
Oh no! Don't say it's going to fail. What's not right? Oh, I see a problem. Yeah.
After the 18.
Okay, so yeah, I'm wrong. I'm wrong. There is another example of me. If you were looking for those, if you were counting those examples of me being wrong, what comes after this? The 18.
16.
16. We didn't have 16 before.
Yeah, we didn't have 16 before. And we can put 16 in for something smaller, I can think of.
You're right. We didn't have 16. Okay, so I'm totally wrong. Jeepers, totally wrong. Okay, and 21 up here. What's the next one here? It's certainly not 16. So let's just say we're wrong. Let's just say, well, instead of saying I'm wrong, why don't we just say that we're wrong? I like that better.
Is it?
Sure.
Okay. Before we go, I do want to show you some beautiful results of this problem if you carry it forward and you start looking for genetic results. A week from today, I'm going to show you even more results. But today, I'm going to show you the results for numbers from going up to, okay, just a sec. I'm going to show you numbers, the results for numbers going up to 9, from 2 to 9. And I'm going to show you how all of those connect. And I just think it's beautiful. So here we go. Okay, and screen share coming up there. Are you ready? The first two numbers to connect. There are no surprises here, folks. It is 2 and 4. There we go. And boom, those are the connections. Okay. Interesting.
Yeah.
So 6 actually takes a long time to connect to 2 and 4.
It's not connected.
It's not connected yet. It will be connected next week. Okay, next week I will show you more results.
Part 2.
Part 2. We're not going to do the puzzle during the class, but if you are interested in this puzzle, you can stay after class, and I will show you the connections after class next week.
I'm gonna tell you something about the animal thing.
Yep.
After a few seconds, I knew. Oh, I see how this is connected to the numbers.
Okay.
That's all I want to say. Bye.
Okay. Take care.
Bye.
Goodbye,
see you
everyone.
next week.
Bye-bye.
Bye.
Bye.
Hello.
Hi there.
After we say goodbye, I say hello. But
Do you want to talk
You
about
say goodbye, and I say hello.
I'm not sure I see the connection between this and what we were just doing, but maybe I'm just.
So these numbers are connected at they're DNA, if you like, are what we've been figuring out. Okay, just like animal DNA. And you can look for differences. And at a certain point, for example, between 3 and 6, those start to repeat after a while. So we can say that those kind of are related. So you can see how many steps, in this case, you can see how many steps it takes for there to be repeats. We did see that for 2 and 4.
Amelia?
Yeah.
Gord?
Yeah, go ahead, Amelia. Yeah. Yes, Amelia.
You're muted.
Yeah, go ahead, Amelia. Yeah.
I just wanted to say that kangaroos are marsupials.
Mm-hmm. Now, I forget exactly when Australia split apart from the rest of the continents, but that is probably the reason why I think that was 90 million years ago that we saw that separation. I believe that's because of that split of the continents.
Mm-hmm.
Yeah.
And that's about all I wanted to say.
Okay. Bye. Solly, did you want to talk about a puzzle, or are you good?
The village, the pillage and I want to say village and pillage because of them.
Oh yeah,
profit.
Pillage and Profit.
I've been playing with my dad, just one every night, and some of them really depend on who goes first and the turn order.
Well, not only that, Solly, all of them depend on who goes first. These are pure strategy games. And either the first player will always win, or the second player will always win if you guys play really well. But you have to play really, really, really well in order for that to be true. Both of them. Yeah.
That's what I wanted to say. Bye.
Oh, it's great. Take care, Solly.
Oh, that was an interesting one. I have a question about the Pillage and Profit one. In terms of just the title of it, do you think that there's anything, with that one in terms of just kind of thinking about the title, in terms of what's going on in the world currently with Russia invading Ukraine? And I don't know, just the title of it just kind of just sort of nibbled at me a bit there.
I struggle with the titles for things because I'm aiming for engagement as my number one objective in the classroom. And I know that in my experience, nasty engages. And I do think that teachers need to also be aware, oh, that child is a refugee. She just came from a region that this game is not appropriate. So I don't see that my games have to be named the way they are. I think you can change the names. But I also, it's the ideas behind them that are important. It's not so much the theme. So I feel very comfortable. And that's a good point that I should bring up to teachers more often, is that reskinning these things is totally fine. For example, with whenever the Julia Robinson Math Festival did my bubbling cauldrons, I have this one where you have 2 bubbling cauldrons and you're dropping in frog number 1 and frog number 2. Which bubbling cauldron would you like to drop frog number 2 into? And so I have this, and I just know I get engagement at a higher level. It's just, I just feel it. And so whenever they redid it, they did it with ladybugs and ladybugs landing on leaves. And if in this puzzle, if I've got a 1 and a 5 in a pot and I try to add a 6, that's 1 plus 5 is equal to 6. Do you want to really put that frog number 6 in there? Then the cauldron explodes. In the case of the ladybugs, you have ladybugs 1 and 5 on a leaf, and the number 6 comes, all the ladybugs fly away. So this is theming, and it's also personality. And I just work with nasty with it in a tongue-in-cheek way. But I'm really happy for people to reskin.
Yeah. Well, yeah. I hear you, and it's easy to. Just think of Star Wars. There's tons of movies and games that kind of go on that theme of sort of a war-based or takeover kind of based idea. So, and it engages all of us, and we're all. So it's easy to do, but I guess I was just sort of thinking about how it might affect some people in the class.
I think that it does affect people both ways, and I think teachers need to be careful, and I think I can just leave it to individual preferences. I'm not going to put in the work to reskin, because that's really not really the essence that I'm trying to get out. I do have some puzzles. I've got a petal puzzle, but on that sheet of paper with the flowers, I have a little bee in the corner. And that means that whenever I'm walking around and I see some guys and they're just goofing off a little bit, I can just say, oh, that bee, I can remember being stung by a bee. And I just take them away, give them a little jab, and say, oh yeah, I can remember. Oh, that hurt. And then, oh yeah, and what did you guys get for the answer? So I use nasty in a really, I really use it to help kids escape from math and then get back into it in a brief breath.
Yeah. Good. Well, thank you for sharing that.
Yeah.